Welcome students to another lesson, and in today's class we'll be looking at Kirchhoff's law. So before we start with Kirchhoff's law, a quick reminder that Kirchhoff's law let me just write Kirchhoff's law here. Kirchhoff's law. Okay. So basically what Kirchhoff's law is that it's an algebraic sum of the current flowing towards a point. So basically what it says that um, the sum of the current in should equal to the sum of the current that will be coming out. So for example, if we have current 1 going in and it's going to be divided into current 2 and current 3, we can say that sum of the current in should equal to the sum of the currents out, right? And I1 would therefore equal to I2 plus I3. So that's basically Kirchhoff's law. So in today's class we are going to look at a couple of examples. Okay, so let's look at the first example. So the first example we have here is a current of 25 amps, right? No voltages. And then we have let's draw it a bit smaller. We have here a current of 25 amps, and it's going into a circuit with a 5 ohm resistor and a 2 ohm resistor, as well as a 4 ohm resistor, and we have an 8 ohms here, and then we have a 2 ohms over here and 9 ohms over here. So how do you solve this question? Basically what they want you to do is they want you to calculate the current. So this is our total current over here. So they want you, the question states, calculate the current in each of these branches. So there is a method that I'm going to show you. So basically what we're going to do is we're going to redraw the circuit. So what I like to do is let's redraw the circuit. We know that 2 and 9 are in series, right? So 2 ohms is in series with 9 ohms, right? Okay, and then we see that they are both parallel with the 4 ohm resistor. Okay, and then we see that the 5 ohms is divided between the 4 and the 2, right? But 5 and 4 is parallel to 2 ohms. And we see that there is an 8 ohms over here. And then we have our current flowing in this side. Okay, so now we have redrawn our circuit, which is much simple, right? So we know we can now simplify it as well. So let's simplify this quickly. So we have 5 here. On top we have 2 plus 9, because it's in series. We have 2 plus 9, which is 11 ohms in parallel. Okay, we have 11 ohms, and it's parallel with the 4 ohms. Then we have 2, and we have 8. So now let's simplify it again. what we're going to do is 1 over, okay, 1 over 11, sorry, 1 over 11 plus 1 over 4 to the minus 1 equals the resistance. So we have a resistance here of 2,9 ohms. So now we have 2,9, right? So we have 5 plus 2,9 ohms is parallel with the 2 ohm, which is parallel with the 2 ohms at the bottom and series with the 8. So then we're going to have to add this. So we add that and we have 1 over 7,9 plus 1 over 2 to the minus 1, and we have a resistor there of 1,597. So now we have to redraw that 1,597, and then we have an 8 ohms over there. Sorry, different color. So we have 1,597 plus 8 ohms, and this will give our total resistance of 9,95 ohms. Okay, so now what we're going to do is, okay, let's focus on this. This is 2 okay, 1 and 1 and 2, okay, they are in series, right? And we know that in series current is the same, right? So the total resistance is equal to 1,597, and the total current is equal to 25 amps. So why is that? It's because of the rules, and the rule states that current in series are the same. So what we're going to do with this is we're going to get the voltage, and the voltage is going to be 19,97 amps. Nope, 97 amps. 39,925. So how did we get that? We got that from this here. Current is equal. So now we got the voltage, right? So we know that the voltage, total voltage here and the voltage here is going to be the same, because the voltage in parallel is equal, right? So we're going to focus over here, right? So now what we're going to do is we can copy and we can get the voltages. Like, this is a long method, like using Ohm's law every time, right? So another method that you can do is you can use the current rule, right? So the current rule is the current at, let's say, so our circuit is this one, right? This is our circuit. Let me just copy it. Copy. So this is the Ohm's law, Ohm's rule, right? That's Ohm's rule. And let's paste it here. Paste. So what we're doing is Ohm's law, but I'm going to quickly show you the current divider. So now we are going to do the current divider, right? Instead of using Ohm's law, which is quite long and I don't think you guys have the time in exams. So for this semester, we'll use current divider and voltage divider, right? So we know that voltage is equal in parallel, right? And we got a voltage of 39 comma 39 comma 925 volts. So we want the current at which point? We want the current at 2. We want the current at 2. Okay, the resistor at 2 is equal to 2 ohms. And the voltage is equal to 39,925 volts. Because it's in parallel, you can see that 2 is in parallel with all of this. Is that clear? Very simple. So the current at 2 is equal to the voltage over the resistor, which is 39 over 2, and then we get a voltage of 15 plus 9 divided by 2 is 4. 15 19.5 amps. Okay, wait, this is 9,9, so this is 9,9 amps, something like that. So there's your answer. That's your current at 2. So now that's how you find the current at 2. So you can do basic maths, and you could just subtract 25 and 19, and that would be your current at 5. So your current at 5 would be 5 amps. All right, and then it divides as well again, right? And the current at 4, basically what we're going to do, current at 4 is equal to the total current multiplied by the sum of the adjacent current over the sum of the adjacent current plus the sum of the current at 4. So what we have is the total current coming in there is going to be 5 amps, right? And then adjacent to that would be 11, because 2 plus 9 is 11, and it's to be 11 plus 4. And then we have an answer of, this answer needs to be less than 5. So let's see, 5 times 11 over 11 plus 4, and then we have 3,66 amps. So over here we have 3,6 amps, and then you could just subtract this, and then you would have 1,4 amps over here, and that's how you get the amps. So I kind of mixed both of the methods. I kind of mixed them, the ohms method and the current divider method. But yeah, so if you use the strictly ohms method, it might take longer to solve this question, and if you use the amp divider method, it's much quicker, but the chances of making mistakes is quite high. So if you do use the current divider method, always come back and double check with the ohms method. So now what we're going to do is move to the next question. We are going to do a couple of examples of Kirchoff's law. So let's look at a quick example. Which we have here is, we have 30 volts over here. Let's clean this. We have 30 volts over here, and we have 9 volts over here, and we have 5 ohms, and we have 9 ohms, and we have 12 ohms. Sorry, that's all we have. And yeah, so what we're gonna do is we have to get equation 1 and we have to get equation number 2. That's basically Kirchhoff's law. So to get equation 1, I'll just use different color. So we're going to break our circuit. We're going to have the 30 ohms, and we're going to have, let's extend this line, we're going to have 12 ohms over here, and we're going to have 5 ohms over here. Pretty straightforward, right? So over here we have our I1, and over here we have our I2, and over here we have our I3, and we know that I3 is equal to I1 plus I2, right? So now we're going to focus on the circuit, and we're going to remove the 9 volts for now. Okay, so let's write down the equation. So it's going to be the sum of the voltage in equals the sum of the voltage out. Okay, not in and out, but the sum of the voltage is okay. And what we have here is the voltage in would be our 30 volts, and the voltage that's resisting would be voltage 1 and our voltage 2. So this would be voltage, no, let's use A and B. This here is A, that's B. So we have 5 I1 plus 12 I3. And how did we get that? We know that voltage is equal to I multiplied by R. So that's now our first equation. That's our first equation. Now let's get the second equation. To get the second equation, we are going to redraw that diagram again, but now we're going to use the 9 volts. So what we have now is the 9 volts, and it is connected with the 12 ohm resistor. At the bottom is the 15 ohm resistor, and now we'll be focusing on the circuit here. So over here we have so let's write the equation. We have our 9 volts, which is coming in, and what's coming out, which is resisting. We have we have the IR, so our current would be I2. This here is I1, that's I3, I2 multiplied by 15 plus 12 I3, and this here is our equation number 2. So now we have 2 equations, and now we will be solving for this equation. So what you're going to do is you're going to multiply. Let's multiply this by 21. Okay, sorry, where was I? Okay, so now we're going to multiply this one by 21. Okay, so now at the bottom what we're going to do is multiply by 12. Okay, how do we get these numbers? Okay, before we do that, we need to correct this equation. So we know that I3 is equal to I1 plus I2 because of the sum of the currents in should equal to the sum of the currents out. Okay, so now what we're going to do is we're going to unpack this. So when we unpack that, we have our 2 equations. So our 2 equations is going to be 30 volts equals to 5 plus 12 is going to be 16, 17, 17 I1, and then we're going to have our plus 12 I2, and here at the bottom we will have our 9 volts, and then we will then have our 12 I1, and we'll have our I2, we'll have our 21 I2. Okay, so now we're going to remove I2. And how do we remove I2? We are basically going to multiply by 12. We're going to multiply by 21, and we're going to multiply by 12. So that gives us 630 equals to 567 I1 plus 252 I2. Then here at the bottom we'll have 108 equals to 144 plus 252 I2. Now if we subtract the 2, we see that we are only left with I1. So we'll have an answer here of 522 equals to 423 I1. And then we can say that I1 is equal to 1, 2, 3 amps. And then therefore you can choose any one of these equations and you can get your I2. You can choose any one of these equations and get your I2. So now our I2 will therefore equals to negative 0, 2, 0, 0, 272 amps. And then I3 is equal to I3 is equal to I2 plus I1, which is equal to 0,953 amps. And there you have it, guys. Pretty straightforward, not that difficult at all. So this will be the last example, and this recording will end shortly after this example. Let me just change this color. This. Okay, so now let's look at an example. Let's look at an example. Okay, let's do this example here. So we have 75 volts, and then we have a 15 ohms So we have 75. Okay, maybe a little thicker. So we have 75 and 5, 15 and 14 and 18 and 16 and 12 and 90. So all of these are batteries, and these are your resistors. Okay, just so you don't get confused. So now we're going to use Kirchoff's law to find current I1, I2 and I3. So over here we have, let's change this color to black. Done. So here we have our I1, and then we have our I2 and our I3 over here. Over here by 18 we have I1 minus I2, and over here we have our I1 minus I2 minus I3. So what we're going to do next is we're going to have to label this. So this will be our, let's get a different color, red. This is gonna be A, B, C, D, E, F, G and H, just so we do not get lost. So now we have that. Let's create our for loop system. So we're going to have loop 1, right? It's going to be A, B, F, E. Very simple. We're going to have 75, 15, 14, and that's basically our first system. And then we have our equation of 75 equals to 15 I1 plus 14 I2. Very simple. Now let's look at the next loop. Let's change this color to something you might see. Orange, 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 orange. So the next loop would be, let's use A, C, G and E. So we have a bigger loop now. We have the 75 and we have the 15, we have the 18, we have the 16, and then we come back. Very simple. So let's write the equation. So that's our first equation. This will be our second equation, equation number 2. And then our answer here will be 75 equals to 15 I1 Then we have a positive 18 I1 minus I2, and then we have our next resistor. Next resistor is a 16, so it will be our 16 I3. So now let's simplify this. When we simplify, we have 75 equals to 33 I1. Let's simplify this. We have 75 equals to 33 I1 minus 18 I2 plus 16 I3. So now let's ignore this. Here's our equation simplified, and here's our other equation. So we have equation number 1 and we have equation number 2. So now let's do a third equation. Get a different color. Let's maybe do green. No, green. Let's do red. So now we're going to focus on our next loop. So now our loop is going to be much bigger than the first one. You can see that the first loop, that's our first loop going down, then our second loop, and now a third loop, which would start from 75 and come back to 75. So let's say A D H E. So A D H E. Very simple method, this one, guys. You can use it almost on all problems. We have here what we call is we have 75 equals to 15 I1 minus 18 plus 18 multiplied by I1 minus I2. Then we have our negative 12 negative 12 I1 minus I2 minus I3, and then we have positive 90 volts. So when we simplify this, we're going to take the 90 and we're going to minus. So we have 75 minus the 90. So now when we simplify this, we're left with 15. Simplified, 15 volts is equal to 45 I1 minus 30 I2 minus 12 I3. So now what we're going to do is solve for them. So now we have three equations. Equation number 1, we have three equations. Equation number 1 is 75 equals to 15 I1 plus 14 I2, and then we have equation number 2, which is 75 equals to 33 I1 minus 18 I2 plus 16 I3, and then we have our third equation, which is negative 15 equals to 45 I1 minus 30 I2 plus minus 12 I3. So we see that we have three unknowns, right? We have I1, I2, I3. So we need to solve for the we need to solve for the unknowns. Sorry. We need to solve for the unknowns. So to do that, basically what you're going to do is you're going to take out your calculator, and then we're going to go to mode 5 equations, and we're going to press number 2. So let's say at mode 5. So this here is going to be, let's put it in red on your calculator. This is going to be your, these are your A values, your B values, your C values, and your D values. So let's use the equation. So let's use number 2. Our A value is 15 equals 2, B value is 14 equals 2, 0 equals 2, D value is 75 equals 2, second one is 75 equals 2, 30, going back, equals, okay. This one is 75, this is 33, and then once you put all the values into the calculator, it will give you an answer for I1 equals to 2,357 amps, I2 is equal to 2,83 amps, and I3 is equal to 3,01 amps. Thank you for joining, and that is the end of our lesson.